Hello students, in this video we'll discuss how to find the area under or inside a parametric curve. Consider the parametric curve. X is f of t and y is g of t, and t goes between a and b. There's our parametric curve. Now I'd like to find the area under this curve, so recall that if I integrate from, let's say, from g of a to g of b, where does y go? From y goes from g of a to g of b of y dx. This formula will give you the area under the curve, or respectively inside, if it's closed, the curve. Because if I integrate y dx, that tells me from the range of y, that's the definition of what the area under the curve is by definition of definite integral. Now I'd like to reparameterize this by the change of variable theorem. What can I say? I can say this is really the integral, so the area is also equal to, by u substitution or change of variable, the integral from a to b of whatever y is. Y is g of t, you're letting y be g of t. And then I have dx. Well, what is dx? dx is f prime dt, f prime of t dt. So this formula over here will give us the area under a parametric curve, or inside a parametric curve. Let's see an example of this. Let's go back to one of our first examples of the cycloid, which we know is a solution to the tautotron problem. So it's a very useful function, a very useful curve. So let's consider, let's let x be theta minus sine theta, and y be 1 minus cosine theta, for theta between 0 and 2 pi. This is just our cycloid. We've done this a couple times before, our cycloid. Okay, so the cycloid looks like this. For one period of cycloid, we do what? Here's 2 pi over here, goes up, the point goes up, comes down. I like to find this area over here. That's the area in question. That's x and that's y. Okay, so let's use our formula over here. Of course, theta is the parameter here, so instead of t's, I'm going to have theta as my problem. So let's do it. So the area is going to be the integral from 0 to 2 pi. I'm going to have my y, which is a 1 minus cosine theta. And then I'm going to have my dx. So what's the dx going to be? The dx is going to be 1 minus cosine of theta. And then I'm going to have a d theta. Okay? So I really have the integral from 0 to 2 pi of a 1 minus what? Minus 2 cosine theta, and then plus cosine squared. I'm immediately going to use the fact that this and this is going to be a cosine squared of theta, and I'm going to use power reduction immediately on that, plus a 1 plus cosine of 2 theta, all divided by 2, d theta. Okay? And so now, of course, the 1 is going to integrate to theta. Then this is going to integrate to what? The cosine is going to integrate to negative sine, so I have a negative 2 sine theta over here, because the derivative of that is exactly equal to that. And now with theta over 2. And then I'm a what? Now I'm going to have a antiderivative of cosine is going to be positive sine, so we have a plus sine of 2 theta all over 4. Theta goes from 0 up to 2 pi. Okay? And of course, the sine of 2 pi and the sine of 0 are 0, so all these terms are going to cancel over here. When theta is equal to 0, both those theta terms give me nothing, so I get a 2 pi over here and a pi over here, so the total answer is 3 pi. So there's 3 pi units squared of area under one crest of the cycloid. Thank you very much.